Welcome everybody. In today's video we're going to talk about section 2.7, solving inequalities with absolute values. Before we begin, let's remember three things. One, you must isolate the absolute value bars first. Two, if you divide or multiply by a negative number, you must switch the direction of the inequality. And three, infinity and negative infinity are always open, so we're going to be using the parentheses. Okay, let's take a look at our first case. Absolute value less than a positive number. So here we have the absolute value of x less than 2. Now less than sounds like and, so that's how we're going to remember this. Less than and. So we have x less than 2 and x greater than negative 2. Now notice in the first inequality I dropped the absolute value bars, but I kept the less than 2 the same. In the second inequality I also dropped the absolute value bars, but I changed the direction of the inequality. So we went from less than to greater than. And I also took the opposite. So the opposite of 2 was negative 2. In this case, we can write this in compact notation, which is negative 2 less than x less than 2. Okay, so once again, we're going to use the three-line method we learned earlier. You'll notice on the vertical bars I have negative 2 on the left and 2 on the right. That's because negative 2 is less than 2. Okay, so our first inequality, x less than 2, the endpoint is not included, so we're going to put a parenthesis on 2. And since it's less than, we're going to shade everything to the left. In our second inequality, x greater than negative 2, again, the endpoint is not included. We'll put parentheses at negative 2. And we'll shade everything to the right. We're looking at an AND statement, so we're going to be taking the intersection of line 1 and 2. This is the part that's overlapping. So we could hopefully clearly see that it's going to be everything in between negative 2 and 2, but not including the endpoints. Alright, this next example is also an example of case 1, but in this case we're going to use less than or equal to a positive number. Once again, less than sounds like and we're going to take a look at our two inequalities. First one, x less than or equal to 2. I just dropped the absolute values and used the same inequality direction and the same number, 2. But in my second inequality, I changed the direction of the inequality and used the opposite of the number. So it's x greater than or equal to negative 2. In the compact notation, it's negative 2 less than or equal to x less than or equal to 2. And we'll go again to our three-line method, which is going to be identical, except we're going to use brackets for 2 and negative 2 instead of the parentheses. Notice in our interval notation we use the brackets as well. In our second inequality, x greater than or equal to negative 2, we'll put the bracket on negative 2, shade everything to the right. And then we'll take a look at our AND statement, which is the intersection, and which is the overlap between lines 1 and 2. It'll be everything between negative 2 and 2 inclusive. That means we include the endpoints. Alright, in case 2, we're going to have the absolute value greater than a positive number. In this example, we have the absolute value of x greater than 2. Greater sounds like or. Greater or. So this is going to be an or statement. Again, to get my first inequality, I'm going to drop the absolute value bars. I'll keep the inequality direction the same and repeat the number 2, so x greater than 2. But for my second inequality, once again, I will switch the direction of the inequality. So I'll go from greater than to less than, and I'll take the opposite of the number. So instead of 2, I'll write negative 2. Okay, so looking again at our three-line method, I have negative 2 and 2 on my vertical bars. My first inequality, x greater than 2, does not include the endpoint, so I'll use a parenthesis at 2 and shade everything to the right. My second inequality, x less than negative 2, again does not include the endpoint, so I'll get a parenthesis on negative 2, and I will shade everything to the left since it's less than. But this time we have an or statement, which is the union operator. So I'm going to be adding line 1 and 2 together. Basically, there's no overlapping, so I'll just be dropping those down to the third line and use the union operator in our solution. Okay, another version of case 2. Again, we're going to use the greater than or equal to a positive number, which is going to be identical. except we're going to use the brackets. Again, it's greater, so or, and we have x greater than or equal to 2, or x less than or equal to negative 2. Using our three-line method, negative 2 and 2 on our vertical bars, we'll take a look at our first inequality, but now that it's greater than or equal, we'll use a bracket and shade to the right. And in our second inequality, it's less than or equal, so we'll use a bracket and shade to the left. Once again, it's an or statement. It's the union, so we're taking lines 1 and 2 and combining them together, which in this case there's no overlapping, so we'll just drop it down to the third line and use the union operator. Note the use of the brackets in the intervals. Okay, so by definition of absolute value, we get some special cases, and some of these special cases you won't need to actually graph anything. Let's take a look at some of the special cases. Okay, our first special case, we'll call it case 3. This is the absolute value greater than 0. Well, we know by definition, the absolute value of any real number is greater than or equal to 0. So in this case, the only number of x we do not include is the one where the expression inside the absolute value bars evaluates to 0. To find this, we'll drop the absolute value bars and solve for 0. So here we have x equals 0. And it's already solved for 0, so we're just going to use the point 0. Notice I put the parentheses to the left and shade everything to the left, not including 0. And I put an open parenthesis at 0 again and shade everything to the right, again not including 0. So my solution will be all the real numbers except 0. And one way to write that is the union operator. From negative infinity to 0, union 0 to infinity. We'll call this one case 4. The absolute value greater than or equal to 0. Well, by definition, the absolute value of any real number is greater than or equal to 0. Therefore, there's no need to draw the three lines. The answer is simply all real numbers. This can be expressed as shading the entire number line, or by interval notation from negative infinity to infinity, or you can use the set symbol for real numbers, which is that bold R. Okay, we'll call this case 5. The absolute value is less than 0. Here, the absolute value can never be negative. Therefore, by definition, there is no solution. We can either write no solution or use the null set symbol. Case 6, the absolute value less than or equal to 0. So this is very similar, except for we do include the point 0. So here, the absolute value can never be negative, but it can be 0. Therefore, you'll have to solve what's inside the absolute value bars equal to 0. The solution will be that value of x. So it'll just be that one number. Okay, so here we are. We drop the absolute value bars and set it equal to 0. We can see the point 0 is what x is, and that is our only point. So in brackets, I put 0. I don't have to use the interval notation here. All right, case 7, the absolute value less than a negative number. Well, this one's easy. By definition, absolute value can never be 0. Therefore, it's simply no solution, which you can just write no solution or use the null set symbol. And another version of case 7 is absolute value less than or equal to a negative number. Again, for the same reason, absolute value can never be negative. Therefore, there is no solution or the null set operator symbol. Okay. Case 7, the absolute value greater than a negative number. Well, good news. By definition, the absolute value of any real number is greater than or equal to 0. Therefore, again, we do not need to draw the three lines. The answer is simply all real numbers. We can indicate this by shading the entire number line, by using the interval notation from negative infinity to infinity, or by using the real number set symbol, which is the bold R. Okay. And identically, case 8, absolute value greater than or equal to a negative number. For the same reason, all real numbers is a solution. We could shade the entire number line, use the interval notation for real numbers, all real numbers, or use the set symbol. Great. Now let's take a look at some examples. All right, our first example, 3 times the absolute value of x plus 1 minus 2 is less than 10. Okay, so the first thing we always have to do is isolate the absolute value bars. To do that, we want to add 2 to both sides. Okay, and when we simplify that, we have 3 times the absolute value of x plus 1 is less than 12. Now we need to divide both sides by 3. And when we simplify that, we get the absolute value of x plus 1 is less than 4. Okay, again, it's less than, so it's going to be an and statement. It's going to be case 1, the absolute value less than a positive number. Okay, so the first thing you have to do is set up the compound inequality. Remember that we're going to be using these 2 inequalities, and we're going to be solving them for x. So we can do them at the same time. The first thing we want to do is subtract 1 from each side of each inequality. And we'll get x less than 3 and x greater than negative 5. Going to our 3-line method, again, negative 5 is less than 3, so it'll go on the left. And we'll take a look at our first inequality, x less than 3. Here, since the 3 is not included, we'll put a parenthesis. Since it's less than, we'll shade everything to the left. In our second inequality, x greater than negative 5, the endpoint again is not included, so we will use parenthesis. But now it's greater than, so we'll shade everything to the right. This was the AND operator, which is the intersection of line 1 and line 2. This is the overlapping, which we can clearly see is all the points between negative 5 and 3. And again, we do not include the endpoints. Let's look at another example. 1/2 the absolute value of x minus 3 plus 1 is greater than or equal to 3. First thing we need to do is isolate the absolute value. To do this, we'll subtract 1 from both sides. Okay, that simplifies to 1/2 times the absolute value of x minus 3 is greater than or equal to 2. Next, we'll have to multiply both sides by 2. And that simplifies to the absolute value of x minus 3 is greater than or equal to 4. Okay, this is greater, so we're going to, it sounds like or, it's going to be an or statement. So that's case 2, the absolute value greater than or equal to a positive number. Alright, so the first thing we need to do is set up the compound inequality. So again, we drop the absolute value bars and keep the same inequality direction, the same number, so x minus 3 greater than or equal to 4. And for our second inequality, we're going to change the direction, so it's going to go from greater than or equal to less than or equal, and we're going to use the opposite of the number, so it's going to go from 4 to negative 4. And again, we're going to solve for x. To do this, we're going to add 3 to both sides of the inequalities. Then we're going to get x greater than or equal to 7 or x less than or equal to negative 1. Again, we'll go to our 3-line method with negative 1 on the left and 7 on the right. In our first inequality, x greater than or equal to 7, here the endpoint is included, so we'll use a bracket, that's 7. This is greater than, we'll shade everything to the right. For our second inequality, x less than or equal to negative 1, again the endpoint is included, so we'll use a bracket at negative 1, and it's less than, we'll shade everything to the left. Again, this was an or statement, so we're going to take the union of line 1 and line 2. We can see there's no overlapping, but again, we're going to be adding the 2 lines together, so it's going to be like we just kind of dropping each one down on the third line, and we'll use our union operator to express our solution. Notice the brackets on the endpoints, and the parentheses at infinity and negative infinity, since there are no endpoints. We always use the parentheses for that. Alright, let's look at another example. The absolute value of x minus 2 plus 1 is less than or equal to 1. First, we need to isolate the absolute value. So we're going to subtract 1 from both sides. That's going to leave us with the absolute value of x minus 2 is less than or equal to 0. Well, this falls into case 6, the absolute value less than or equal to 0. This means we need to drop the absolute value bars and set it equal to 0, because absolute value can never be less than 0, so the only time it will be true is when it's equal to 0. So we're going to add 2 to both sides of that equation, and we'll get x equals 2. So this is the point we're going to include. So we'll label 2 on our number line, and we'll shade the point. Now you'll notice the answer is in brackets 2. We do not need to include interval since it's only 1 point. Let's look at it. Here, we have the absolute value of x minus 2 plus 1 is greater than 1. Again, we'll isolate the absolute values. So we'll subtract 1 from both sides. And now we get the absolute value of x minus 2 is greater than 0. Well, this falls into case 3. The absolute value greater than 0. So remember, what we have to do here is we have to drop the absolute value bars and set it equal to 0. So again, we add 2 to both sides. And again, we get 2. But this time, this is the only point we do not want to include. So we'll label 2, and we're going to put a parenthesis on 2 and shade everything to the left. We put another parenthesis on 2 and shade everything to the right. Then we can take the union of these two sets. So again, this is all the real numbers except for the point 2. Alright, let's look at this example. 2 times the absolute value of x plus 2 plus 4 is less than or equal to 2. First thing we need to do is isolate the absolute values. So we'll subtract 4 from both sides. That simplifies to 2 times the absolute value of x plus 2 less than or equal to negative 2. Now we need to divide both sides by 2. And when we do that, we get the absolute value of x plus 2 less than or equal to negative 1. Okay, well this is case 7, the absolute value less than a negative number. Now, the absolute value can never be negative, therefore, there's no need to draw the 3 lines. The answer is simply no solution. This can be expressed by writing no solution or using the no set operator symbol. Here we have the example. Negative the absolute value of x plus 2 is less than or equal to 1. First thing you have to do is isolate the absolute values. To do that, we'll multiply both sides by negative 1. When we do this, you'll notice we're going to have to switch the inequality. Since we're multiplying by a negative number, we'll also have to do that if we divide by a negative number. So we'll have the absolute value of x plus 2 greater than or equal to negative 1. Well, this is case 8, the absolute value greater than or equal to a negative number. Okay, so in this example, we have the absolute value of x plus 2 greater than or equal to negative 1. Well, by definition, absolute value of any real number is greater than or equal to 0. Therefore, there's no need to draw the 3 lines. The answer is simply all real numbers. This we can show by shading the entire number line, using the interval notation for real numbers, which is all from negative infinity to infinity, or using the real number set symbol, which is the bold R. Alright, that concludes the video. Hope you learned something. And of course, there's lots of examples in your book to practice. Have a great day.